Hello all and welcome to another Water Drop edition. The aim of this video is to highlight how we can integrate multiple Autodesk offerings by making use of the powerful tools that each product may have to improve our workflows. This video shows specifically how we can use the Watershed analysis tool in InfraWorks to create catchments and then import them into InfraWorks ICM to make use of its many hydrologic and hydraulic capabilities so that we may accurately size up drainage infrastructure. This workflow could be applied to examples such as major infrastructure cross-drainage design for roads, highways and rail drainage, hydrologic studies, or dam or reservoir sizing, for example. We're going to start off in InfraWorks, Autodesk's conceptual design software, to quickly bring together extensive data from various sources for our particular area of interest. So we can quickly build these out with the model builder, which will gather a lot of this information for us automatically, or if we have better data like higher resolution terrain models or more recent aerial imagery, we can manually build these into a new model. Now, InfraWorks does have some great built-in drainage design tools, allowing us to model watersheds, culverts, or drainage networks along a road, for example. We're going to be focusing on the watershed or catchment and stream flow generation tools. In this example dataset I have here, we're looking at a design for a proposed highway upgrade along this stretch of the motorway here. And we need to identify and estimate flows for cross-drainage infrastructure like culverts. So our first step is going to be to define the catchment areas. So one of the ways that we can get an initial idea of the contributing areas and streams is via the terrain theme. So I've set one up here that kind of gives us an indication of the streams that are crossing this particular stretch of the motorway and kind of a look at the catchment areas. So it looks like we're going to have one or two here, some along here, and there's another stream crossing down the bottom here. We could also help to identify any of the crossing points for culverts by maybe getting the profile view of the road I have here and identifying any low points. So watersheds or catchments can be created in InfraWorks via the Analyze tab and the Watershed tool. And there are a number of ways which we can create these, such as by selecting at points manually to generate a catchment upstream, or we can select a component road like I have here and let InfraWorks analyze that road entirely and generate catchments for us, or I can select a proportion of the road for the analysis to perform on. First, I'm going to select an individual point. And once I select that point, we're going to get a window pop up that will ask us to set up any grid spacing or stream threshold settings. So the grid spacing will let us control the size of the square grid sampled for our streams, and the stream threshold will set the number of grid cells used to define these streams. Essentially, this is giving us an option to either identify smaller streams with more precision or the ability to analyze the watersheds faster. So the more coarse we have this, the quicker these watersheds or catchments will be generated. I'm going to set the grid spacing to 10 and then hit enter for this first one. Okay, so now we've created a catchment for a known point the known creek crossing. Now I'm going to perform this on the component road here. Again, I'll drop this down to 10 and then run the watershed analysis tool. So now that we have our catchment areas defined, we can begin to get an estimate of our peak flows. In InfraWorks, there are two hydrology methods available for calculating these peak flows. So in the hydrology data section, we can select either the rational or the regression method for these calculations. Otherwise, we can manually enter some known flows in the user-defined field. Now I've set up some peak flows already in a separate proposal. So I'll just jump to that. I'm using the rational method to get an estimate, and what's required is a runoff coefficient and our rainfall intensity. So we can grab these rainfall intensity values from specifications, guidelines, or national websites that collect data in various locations. So my area of interest is in Australia, and I'm getting my rainfall intensity from the Australian Bureau of Meteorology. And for my 100-year rainfall event or my 1% AP event, I'm getting a value of 107 millimeters per hour for my 1 hour storm. So I've entered that into InfraWorks, and then I'm getting an estimate of the peak flows at my point of interest or my potential culvert crossing, which is 12.4 cubic meters per second. So now that we have this peak flow, we could use it to help with the preliminary design of culverts in InfraWorks. However, we will be conducting this in ICM to take advantage of its many available runoff routing and volume models, as well as the advanced 1D hydraulic engine and built-in culvert design options to model losses associated with these structures for a more accurate design. Additionally, we can take our analysis further and carry out some flood simulations in ICM to understand the impacts of the new development on any adjacent properties. So to do that, we're going to bring our catchments into InfraWorks ICM, and we're going to export them via geodatabase option. We're going to select our folder to export these to. So I'm using the ACC docs via the desktop connector. So I'll save that there. And then I'm just going to bring in my catchments only. So we could also bring in the locations of our culverts, which are our points of interest, but I've already set these up in ICM. And then I'll accept the defaults here. And then we can bring these into ICM. So this is my model in InfraWorks ICM. I've brought in that aerial image, some background layers for my roads, and I also have the proposed culvert crossing locations. So in ICM, for our culverts, we can also define the culvert inlet parameters. So there's a range of built-in options available here, which is going to help us get a better estimate of the losses or the energy losses that occur at these structures, which can help us get a better estimate of the hydraulic properties at the upstream and downstream end of the culverts when we're analysing them. To import the catchments, we're going to open the Open Data Import Center. These are going to be imported as subcatchment object types in ICM. We've got our geo database as our source type, and I'll just navigate to that folder. Our feature is the watersheds, and we're just going to map one of the fields, which is the ID, as ICM will automatically get the areas for us. Then we can import the new 5 catchments into ICM. Now we're going to complete our hydrology, and we're going to open up the properties of one of our subcatchments. We can see we've already got the area defined, and one of the first things we might do is tell ICM where that subcatchment is drained to, and in this case it's the upstream end of our culvert here. So subcatchments in InfraWorks ICM work in 3 tiers. At the top we have our polygon or subcatchment area, and then we assign a land use to these subcatchments. Land uses can be made up of up to 12 different runoff surface areas, but usually these are just looking at a pervious and impervious portion. Within these runoff surface areas, this is where we can define the routing model or the runoff volume model that we're using to produce our hydrographs leading into our catchments. So in ICM, we have a large number of different runoff routing models, which describes how the flow moves over the surface. We also have a large number of runoff volume models available, which will let us know how much of that rainfall that is converted to runoff when it hits that surface. So all this can be made easier in ICM through the use of stored queries or SQLs. Now we do have additional workflow videos which can help give a better understanding of how to set these up and use them in ICM. I've created a couple here, and the first one here allows me to create a new land use. So this will generate a prompt. For its urban areas. This will let me define a % of impervious for these catchments, any losses that are experienced in the impervious portion of the catchment, the Manning's roughness, or any losses experienced in the impervious portion. So that'll create a new land use where I can come in and set that up. Otherwise, I can then use another stored query here. So I'll select all my subcatchments and then drop that on. And what this will do is set the land use for all the catchments I've selected. So it's that simple. Additionally, there are many ways that we can generate rainfall in ICM. So we've got some built-in design rainfall generating tools, which are based on guidelines or codes for many different areas around the world. So there's a full list here. Otherwise, we can build out these rainfall hydrographs just using the rainfall import tools or building tools. So my particular model here, this is a look at the rainfall that I'm going to use for the simulation. And I've already run these in a model. So now I've got my results. So I can use the graph pick tools for any of these catchments to have a look at the total outfall. And we can see here for this particular catchment, it's estimating that we're getting flows at almost about 9 cubic meters per second, as opposed to the 12 that we were getting in the InfraWorks model. So it looks like that's maybe overestimating the flows slightly. But what else we're getting in ICM as well is the total volume of flow coming towards that catchment and all the timing of the different peaks as well. We can use these tools to have a look at the depth of flow in our catchment. Also, we can have a look at the types of flows as well. And we can even view the culvert performance in some of these long section views, where we can inspect the depths, flows, or velocities, for example. All of which can help assist us in accurately sizing up the culverts for these particular locations.